Soviet ekranoplans were among the most unconventional and ambitious engineering projects of the Cold War, representing a hybrid category of vehicles that exploited the aerodynamic principle known as ground effect. This phenomenon occurs when a wing moves very close to a surface, such as water, creating a cushion of compressed air that increases lift and reduces drag, allowing for efficient high-speed travel at extremely low altitudes. Unlike traditional aircraft, which are optimized for high-altitude flight, ekranoplans were specifically designed to operate just a few meters above the sea surface, effectively riding this aerodynamic cushion. The concept was developed in the Soviet Union under the direction of Rostislav Alexeyev, a pioneering naval engineer who had already achieved success with hydrofoil vessels. His insight was that ground effect could be used to create vehicles capable of transporting large payloads at speeds far exceeding those of conventional ships, while avoiding many of the vulnerabilities of aircraft. Development began in the 1950s, during a period of intense technological competition between the Soviet Union and the United States. The Soviet military quickly recognized the strategic potential of ekranoplans. Their low-altitude flight made them difficult to detect by radar, particularly over the sea, and their speed allowed rapid deployment of troops, equipment, or weapons across large distances. One of the earliest and most iconic prototypes was the Caspian Sea Monster, a massive experimental craft tested in the Caspian Sea. With a length of nearly 100 meters and a weight exceeding 500 tons, it was one of the largest flying machines ever built. Its unusual configuration, featuring multiple jet engines mounted on the forward fuselage, was designed to blow air under the wings during takeoff, increasing lift and enabling the vehicle to rise into ground effect. Western intelligence agencies, upon discovering it via satellite imagery, were initially baffled by its purpose, giving rise to its famous nickname. Technically, ekranoplans combined features of aircraft and ships in a unique way. They had large, low aspect ratio wings optimized for stability in ground effect, powerful turbofan or turbojet engines, and a hull shaped like a boat to allow takeoff and landing on water. Their cruising speeds typically ranged between 400 and 500 kilometers per h, far surpassing conventional naval vessels, while their payload capacity could include heavy cargo, troops, or missile systems. However, their operational envelope was limited. They required relatively calm seas, as high waves could destabilize the craft, and their low flight altitude demanded highly skilled piloting and precise control systems. Among the operational designs, the Lun-class ekranoplan represented the militarization of the concept. Equipped with large anti-ship missiles mounted on its back, it functioned as a high-speed strike platform capable of approaching enemy fleets with minimal warning. Another important model, the A-90 Orlyanok, was designed for amphibious assault and transport missions, capable of carrying troops and armored vehicles and deploying them directly onto shorelines. These vehicles reflected the Soviet vision of rapid, flexible maritime operations, particularly in strategic regions such as enclosed seas where their advantages could be maximized. Despite their impressive capabilities, ekranoplans faced numerous technical and logistical challenges. Their dependence on favorable sea conditions limited operational reliability, while their size and complexity made them expensive to build and maintain. Additionally, they occupied an ambiguous category between aircraft and ships, complicating regulatory frameworks and military doctrine. With the collapse of the Soviet Union in 1991, funding for such experimental programs disappeared, leading to the abandonment of most ekranoplan projects. Today, they remain a striking example of Cold War innovation, demonstrating how engineers pushed the boundaries of physics and design to create machines that blurred the line between air and sea. And they continue to inspire modern research into high-speed maritime transport.